Topic for Lesson 10.3 is arcs and chords. You'll recognize and use relationships between arcs and chords, recognize and use relationship between chords and diameters. How do the grooves in a Belgian waffle iron model segments in a circle? Waffle irons have grooves in each heated plate that result in the waffle pattern when the batter is cooked. One model of Belgian waffle iron is round, and each groove is a chord of the circle. The endpoints of a chord are also the endpoints of an arc. If you trace the waffle pattern on patty paper and fold along the diameter, segment AB and segment CD match exactly, as well as arc AB and arc CD. This suggests the following theorem. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So abbreviations would be read the same way. So for example, this is kind of the exact same thing. If AB is congruent to CD, which we could put tick marks on there, then arc AB is congruent to arc CD, and since it's an if and only if, we remember that the reverse is also true. So if the chords are congruent, then the arcs have to be congruent as well. The chords of adjacent arcs can form a polygon. Quadrilateral ABCD is an inscribed polygon because all of its vertices lie on the circle. Circle E is circumscribed about the polygon because it contains all of the vertices of the polygon. Spoiler alert, a circle can also be inscribed in a polygon, so the polygon is circumscribed about the circle. You will learn about this in Lesson 10.5. A logo for an advertising campaign is a pentagon that has 5 congruent central angles. So that is going to make each one of these arcs also congruent because the measure of the arc is related to the measure of the central angle. And they ask us to determine whether PTS, let's see, where are you? PTS, so that takes up 2 of our chords, is congruent to PAS. PAS, that takes up 3 of our chords. So that would be no. We could figure out the measures, but enough for us to say that 2 does not equal 3. The rotations of a tessellation can create 12 congruent central angles. Determine whether arc PQ is congruent to arc ST. Okay, so if we took 360 and divided by 12, we could get the measure of each one of those central angles. So PQ, and we're looking at ST. Oh, they overlap, don't they? Well, I can figure out each one. PQ is made up of 5 of those angles, so 5 times 20 is 100, and ST is made up of 1, 2, 3, 4, 5 also. So this one is going to work. They are the same. Diameters that are perpendicular to chords create special segments in arc relationships. Suppose you draw a circle C and one of its chords WX on a piece of patty paper and fold the paper to construct the perpendicular bisector. So that's perpendicular and it goes through the center of WX. You will find the perpendicular bisector also cuts arc WX in half and passes through the center of the circle making it contain a diameter. This is formally stated in the next theorem. In a circle, if a diameter or radius is perpendicular to a chord then it bisects the chord and its arcs. So if BT is perpendicular to V, then UT is congruent to UV, and arc AT is congruent to arc AV. Circle W has a radius of 10 centimeters. Radius WL is perpendicular to chord HK, which is 16 centimeters long. If the measure of arc HL is 53, find the measure of arc MK. Well, if HL is 53, then LK is also 53, and since MKL is a semicircle, all we need to do is take 180 minus 53, and we get 127. Okay, off the same diagram, they ask us to find the length of segment JL. Now, before I can find JL, I'm going to find JW. So they told us in our original problem here that circle W has a radius of 10 centimeters. So that means that all of the radii are 10, including WK, or we could have drawn in WH. And since this radius is perpendicular to the chord, it cuts the chord in half. So what was 16, half of 16 is 8. So now I have one leg and the hypotenuse of a right triangle. So a squared, I have x this time, plus b squared equals c squared. Should be pretty familiar. So we get x is 6. So then again, if the whole radius was 10, 10 minus 6 will give us 4 for our JL. And of course, they gave us units, so we should use them, 4 centimeters. In a circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. Chords EF and GH are equidistant from the center. The radius of circle P is 15 and EF is 24. Find PR and RH. Okay, well, I'm going to go out of order here because we already know what RH is going to be. Since they are equidistant, EF is equal in length to GH, so to get RH, all we have to do is take 24 divided by 2. All right, we don't usually do that, but there it was so easy we had to. Okay, so Q, F, RH, GR, EQ are all 12. And since they said they are equidistant, these segments must be perpendicular, because that's how we measure distance, is with perpendiculars. Looks like we have two legs of a right triangle again. They want us to find PR, which would be the same as PQ. Doesn't matter. I'm going to call it X, because we like X. So X squared plus 12 squared equals 15 squared. 12 squared is 144. 15 squared is 225. And subtract 144 from both sides of the equation. We get x squared equals 81. So x equals, usually we'd say plus or minus 9, but we're looking for length, so we're just going to call it 9. And x is what I was using to represent PR. So P. So we have PR is 9 and RH was 12. Summing things up, the endpoints of a chord are also the endpoints of an arc. Diameters, perpendicular chords bisect the chords and intercepted arcs.